So today we're going to cover chapter 4, section 3, but of section 3, we're splitting it up, so this will be 3C. And today we're going to learn how to graph ellipses, which look like ovals. So let's go ahead and take a look of the definition of an ellipse. And this is we're going to first show you what it looks like, and it's going to either be horizontal or vertical. So an ellipse is the set of all points, x, y, in a plane, the sum of whose distances from two distinct points is going to be constant. And those distinct points are going to be called the focus points. Here, the plural of focus is foci. So what we're going to be looking for are two of them. When we did the parabolas, we only had one focus point. Now we're going to have two. And this is going to be when our center is at 0, 0. Then we'll also see when the center is at a different order pair, and that will involve H and K again. So when our ellipse is longer across the x-axis or around the x-axis, it's going to be a horizontal ellipse. And in our ellipse, we have a minor axis and we also have a major axis. We also will have covertices. The covertices are going to be the endpoints of the minor axis, and the vertices are going to be the endpoints of the major axis. The focus points are going to be on that major axis. It's going to be on the same axis as your vertices. Now, when we have it horizontal, the equation when your center is at 0, 0, and we're going to see this coming up on the next slide, but just to show you, the equation is going to be x squared, and then it's going to have an a squared, and then a b squared underneath there, and it's always going to be set equal to 1. Now, we're going to keep it where our x squared and our y squared are always going to stay in the same spot. What's going to move is the a squared, b squared. The a squared is always going to be the larger number. So my a squared is going to be bigger between a and b. So it's always the larger number. And wherever the larger number is, this is going to tell you if your graph is horizontal or vertical. So notice here, a squared is under x squared. So this tells me that my graph is horizontal. If the a squared were under the y squared, like in this case, then my ellipse would be vertical. It would be longer along the vertical axis, or it would be longer up and down. Now, what we're going to end up doing is square rooting a, and once we square root a, we get a squared, we get the value of a. And a is going to be the distance from the center to the vertex. So a is going to be the distance from our center to the vertex. Our b value, once we square root b squared, this is going to be the distance from the center to the covertices. And remember, the covertices are the endpoints of your minor axis. And if you notice, when the center is at 0, 0, your vertices are going to just have either, it'll be plus or minus. So when it's horizontal, your vertex or your vertices are going to be plus and minus a, comma 0. When the center is at 0, 0 and the minor axis is going to be the y-axis, then it'll be 0, comma plus or minus b. And you can see what this is up in the picture. Now, however, to find c, we're going to use a variation of, looks sort of like the Pythagorean theorem, but we're going to see that on the next slide. Just know that our c value, once we square root c squared, this is going to be the distance from the center to the foci. So distance from center to the foci. The foci is always on the major axis. So it's near that vertice, just like with the parabola. So let's go ahead and take a look at it in the next slide. It's sort of like in table form. And I'm going to show you the formula to calculate our c squared. So for the next slide, it's a nice little table here. Now, what we're going to do is, technically, for SAT purposes, you can move your x and your y and just flip it because you're adding it, okay? But what we'll try to always do is leave the x squared first, and what we'll move is the b squared and the a squared. However, technically, because addition is commutative, you can also see it this way. And then notice these are all the rules that you can memorize for the location of the vertices, the foci, and the covertices. Now, in order to calculate the value of c, we're going to use what sort of looks like the Pythagorean theorem, but it's c squared equals, and it's right here, a squared minus b squared. We're going to be able to get our a squared and b squared from the equation. And then we're going to just take those two numbers and subtract them, and then that'll give us c squared. Now, if we want c, we would have to square root it. Another thing that you need to remember or memorize, that the length of the major axis is always equal to 2 times a. The length of the minor axis will be 2 times b. So just some facts that you're going to need to remember. Now, I know it's a little bit overwhelming, but as we start to do examples, it'll be a little bit easier and you'll see what I'm talking about. So here's our first example. Now, in WebAssign tonight, what they're going to ask you to do is calculate the eccentricity of these ellipses. Now, the slide for the eccentricity of an ellipse isn't until slide number 10. However, all you need to know for eccentricity is the following formula. Just know it's a ratio, and it's going to be, so this is ECCENTRICTY. It's actually going to be slide number 10. And you're just going to memorize the formula that E is equal to C over A. And if you have a radical for your A, you don't need to rationalize it. You can just leave it. And you don't even have to simplify the radicals when you're entering it in WebAssign. So it'll let you enter it unsimplified and unrationalized. I don't believe we're going to test you on eccentricity, but just be aware of it for standardized test. So let's go ahead and take a look at our first example. Now, notice nothing is being added or subtracted to the x squared, y squared. Nothing in a parenthesis where we would see an h and a k. Now, remember, the standard form has to be equal to 1. So we need to set this equation equal to 1. So what we're going to do is we need to divide all 3 pieces by 64 to get our equation equal to 1. So then I'm going to go ahead and remember the standard form of these equations when the center is at 0, 0 were fractions. The way the equation was given to us at the beginning, there were no fractions. But now as soon as I divide everything by 64, I now have some fractions. So I'm going to simplify each one of these fractions. So the first one, 4 over 64, that'll simplify to 1/16. So I'm just going to simplify it to x squared over 16. I really don't need to show the 1 in front of that x squared. Nothing to simplify with the y squared. And then 64 divided by 64 is 1. Now, in order to determine which axis is major, I'm looking for the bigger denominator. The bigger denominator is always your a squared. So my major axis, since my bigger number is under y, my major axis is going to be vertical. So because the 64 is under the y squared, this tells me my major axis is going to be vertical. It's the y-axis. So my ellipsis is going to be longer up and down. So let's go ahead and let's pull out our a and our b value. So remember, since the bigger number is always a squared equals 64. My b squared equals 16. I need to find the values of a and b because that's what I'm going to use to turn into my vertices and my co-vertices. So once I square root 64 and 16, this will give me my a and b value. So a is equal to both plus and minus 8. B is equal to plus and minus 4. I need to find my c value for my focus. So c squared equals a squared minus b squared. A squared was 64. B squared is 16. I'm going to subtract it. Now this I'm going to have to simplify and leave in simplest radical form. So I have to square root it. I can do a factor tree here for 48. I know it's 16 times 3. You could do 6 times 8, but you got to keep breaking it down. So the square root of 48 is 4 square root 3. So my c value is going to be plus and minus 4 square root 3. Now I need to find the order pairs for my vertices. So remember, our center here is going to be the order pair 0, 0. Nothing was being added or subtracted to the x squared and y squared. My vertices, when my center is at 0, 0, in this particular case, we can see that the vertices, since it's the major axis is y, it's going to be 0, comma, plus or minus a, because a is going to determine the location of the vertices. And again, the major axis is y, so that's where I put a. So my vertices are located at 0, comma, negative 8, 0, comma, positive 8. My co-vertices, I use my b value. And my minor axis was the x. So here I'm going to be putting plus and minus b, comma, 0. So negative 4, comma, 0, positive 4, comma, 0. So I'll go ahead and I'm going to graph my vertices in blue. I need to graph these. My co-vertices are going to be in red. I'm going to do my center in green. And then now I also have to do my foci. So for my focus points, I'm going to be doing, they're on the major axis, so it's 0, comma, plus or minus c. So my focus points are going to be 0, comma, negative 4 root 3 and 0, comma, positive 4 root 3. Now I'm graphing these, so I'm going to need to approximate the square root of 3. So the square root of 3 is probably about 1.7. So I'm going to be doing negative 4 times 1.7. So when I graph these, it's going to be 0, comma, negative 6.8. And then this one would be 0, comma, positive 6.8. So now I'm going to go ahead and get these 7 order pairs on my graph. I have 2 focus points, 2 co-vertices, 2 vertices, and the center point. Now again, WebAssign's going to ask for the eccentricity. So E is equal to C over A. So all I have to do here, you can even enter it as the square root of 48 over 8, or you can enter it in as 4 square root 3 over 8, but then simplify this, and this would become square root 3 over 2. But I'm pretty sure WebAssign would take it just like that, okay? We will probably not give you a question to find the eccentricity on the test, but be aware of it for SATs. So let me go ahead and graph this. So let's go ahead and graph. So I'm just gonna put my X and my Y axis here. And I'm not even gonna add little marking. Well, I guess I could. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so my vertices I'm gonna do in blue. They're at +8 and -8. My co-vertices are at -4 and +4. My center point here is at 0, 0. Remember, your foci are always on that major axis, and we're going to approximate those to about 6.8. So 1, 2, 3, 4, 5, 6. So in between 6 and 7. Yes. Now connect the red and the blue dots. I don't want to see you graph them like lines. This is an ellipse, it's an oval. So sort of add a little bend to it. So we got to connect the red and the blue. And maybe I'll do this in another color. So we're connecting red and blue, and you're making an oval shape. It's not straight lines. You need a bend to it. You're doing the WebAssign homework. When you're entering the vertices, it's going to ask you to enter the smaller vertice first. So you see how when I wrote it in that blue box, I put 0, -8 first, and then 0, +8 second. So WebAssign is going to want you to put the smaller vertice first. So if you have a negative and a positive, you put the negative in first. So just read how WebAssign wants you to input your answers. Label this. So my vertices are in blue. These are vertices, the endpoints of the major axis. These are my co-vertices in red. My center is the green, and then my foci are the purple.
Thank you.
Mm-hmm. Okay, so this one's already set for me. I don't have to divide anything. It's already set equal to 1. I need to look for my bigger denominator. The bigger the denominator, the bigger number is your a squared. So my a squared is going to be 9. My b squared is 5. So in order to get a, I have to square root. And a is equal to plus and minus 3. B, I need to square root. And b is equal to plus and minus the square root of 5. Now for my c value, remember c squared equals a squared minus b squared. I'm going to plug in 9 for a squared, 5 for b squared, subtract them, and then square root it. C is equal to plus and minus 2. Now I need to find my vertices. So my vertices, use the A, and remember whatever your major axis is or wherever that a squared value is, that's where you're going to put the a value. So notice it's under x squared. So when I go to fill it in, I'm putting the a value in the x spot. So my vertices are going to be -3, 0 and +3, 0. These are my vertices. I need to do the co-vertices. So for the co-vertices, notice the b squared was under y. So when I go to fill this in, it's going to be 0, plus or minus b. So this will be 0, -square root 5 and 0 comma positive square root 5. Next, I need to get my foci points. So for the focus points or the foci, what we're going to do, it's on the major axis, so plus or minus c comma 0. So this will be negative 2 comma 0, positive 2 comma 0. Now here for the covertices, the square root of 5, it's in between the square root of 4 and the square root of 9. It's probably closer to the square root of 4, which is 2. So I'll say this is about 2.2 or 2.3. It's probably about 2.23. So now I'll go ahead and I'm going to graph the covertices in red, my foci in purple, and then again, remember your center point was it's going to be in green, it's 0, 0. Now for the eccentricity, that you're just going to take your E and remember it's C over A. So your C value was 2, your A value is 3. So it's just 2/3. So let's go ahead and graph it. Let me make my X and Y axis. So I've got 1, 2, 3, 1, 2, 3. The endpoints of my major axis are negative 3, positive 3. My covertices are about 2.2, so it's less than 3. It's the shorter axis. I'll do those in, let me do my center. So this is the center. These are the vertices. Then I'll do my covertices in red. So this will be 1, 2, 3, 1, 2, 3. So my covertices are here. And then the focus points. So I have a focus at negative 2 and positive 2. So now go ahead and connect the red and the blue. And again, add a little bend to it because it's an oval shape. This is an ellipse. Next is a little chart here. Now this is when our center is no longer at 0, 0. It's at a different order pair. And that order pair will be H and K. And then there's 2 different variations. Again, we're going to try to keep our x squared in the same spot. What we're going to move is a squared and b squared. So instead, this one, another variation of this would be x minus h squared. And this time the b squared would move. And then y minus k squared, a squared, and then it equals 1. Technically, these 2 things are the same because, again, addition is commutative. Now, this time, what we have to do, instead of having like plus or minus a comma 0 when it's horizontal, we have to now take that a value and add it to the h. And when it's horizontal, we would be adding k and a. So here we're just going to have to add the a and the b and the c versus having zeros in our order pairs. So let's try an example. So again, always make sure that your equation is set equal to 1, and then we can pull our a squared and our b squared out. Remember, the bigger number in the denominator is always your a squared. So between 9 and 16, I can see that 16 is the greater number. So my a squared is 16, and my b squared is 9. Remember, to get c, we're going to use this formula. So remember, to get a, we square root it. And a is going to equal plus and minus 4. Square root the 9. And our b value is plus and minus 3. And then to get c, we're going to do 16 minus 9. C squared is equal to 7. I've got to square root it. And my c value is plus and minus the square root of 7. The square root of 7 is going to be approximately 2.6. Because again, it's between the two perfect squares, 4 and 9. And again, it's closer to 4 than it is 9. Or it's in between, like halfway in between. A little bit more than halfway. All right, so now, this time, our vertices are a little bit more involved because now we're going to take the a value and we're going to add it. So, for my vertices, I'm using the a value. Notice my major axis is y because the 16 is under the y squared. So, I'm going to go ahead and I'm going to add positive and negative 4 to the y of my center. So, let me pull that out. My center point, remember, is the HK. So this is H, this is K. So my center is the ordered pair, and it's backwards of what it looks like, positive 2, negative 1. Opposite signs on both. So now, to get my vertices, I'm going to be using H, comma, K, plus or minus A. Because remember, a squared was under the y. And remember, in your ordered pair, the first number is x. In this case, it's the h. And the second number is k, which is the y. So now I'm going to be doing 2. And then my k value is negative 1. First, I'm going to go ahead and subtract 4. And then I'm going to do negative 1 plus 4. So my two vertices are located at 2, negative 5. And 2, positive 3. These are my vertices. My co-vertices, I'm adding the B to the H. So for my co-vertices, my formula is going to be H plus or minus B, comma K. So my H is 2, my B is positive and negative 3. So first I'll subtract 3, and then my K value is negative 1. So this becomes negative 1, negative 1. And then I'll do 2 plus 3, comma negative 1. And this gives me 5, negative 1. These are my co-vertices. Remember your foci, or your focus points, you're going to take the C value, and it's on the same axis as your major axis. So for my focus points, it's going to be H, comma, K plus or minus C. So the same thing you're doing for the vertices, but instead of adding A, you add C. And again, these are radicals, so it's going to be 2, and then it's negative 1 minus square root 7. And I just leave it like that, 2, comma, negative 1 plus square root 7. So if you're listing the focus points, you're going to list them in radical form. However, as far as graphing purposes, you would approximate the square root of 7, and we said that's about 2.6. So for graphing purposes, so this is how you would list them. However, for graphing purposes, you would do negative 1 minus 2.6. So 2 comma negative 3.6 would be what you would graph. And then here negative 1 plus 2.6. So 2, and then you would get 1.6. So this is what you would graph for the approximation. So let's go ahead, and again, your eccentricity here, your E value is going to be C over A. C is square root 7, A was 4. So let's go ahead and graph. Again, the 7 ordered pairs. Center this time is not at the origin. It's at positive 2, negative 1. Let me go ahead and make my X and Y axis. So I've got my vertices. Let me go ahead and add some markings here. 1, 2, 3. Let's see, how far do I have to go for X? Just over to the 2. 1, 2, 3, 4. 1, 2, 3. Okay, so for my vertices, it's going to be the order pair 2, -5 and 2, +3. These are the vertices. My co-vertices, or my center, let me do my center first, 2, -1. And then my co-vertices are located at -1, -1. And then 5, -1. 4, 5, and then -1. And now let me put in the focus points. So I have one at +2 and -3.6. Probably around there. And again, just approximate them. Just make sure they're on the correct axis. And again, we're going to connect the red and the blue order pairs or dots. And again, make it nice and curvy because it's an ellipse. We're not drawing diagonal lines. And there's your ellipse. All right, so the next one, notice it is not set equal to 1. So what I need to do is divide everything by 1. So really what I could do is turn these into fractions right now. So it's 16/1, y -3 squared over 1. So what I'm doing here is dividing everything by 16, which really I'm just multiplying everything by 16. Because then this becomes a 1. This one becomes x + 3 squared over 64, 4 times 16. And this just becomes y -3 squared over 16. Now I have it in the correct format to get my a squared and b squared out. Let me go ahead and pull out my center. Center backwards of what you think. Remember, it's h and k. So my h is going to be -3 and my k is +3. Backwards of what you think. So my a squared is always the bigger number. It's the 64. My b squared is the 16. And remember, to get c squared, I'm using this formula, a squared minus b squared. So let me square root to get the a and the b values. So a is equal to plus and minus 8. B is equal to plus and minus 4. And then c squared is going to be 64 minus 16. And that's 48. And then I'll square root it. And I end up with square root of 48, but then I got to break it down. So plus and minus 4 square root 3. I already broke down 48 in the other example. Okay, so now I need to find my vertices, co-vertices, and focus point. So remember, vertices, always use the a value. And notice the a squared was under the x squared. So this is where I'm going to add my a value to the x of that center, which is the h. So for my vertices, it's going to be h plus or minus a, comma k. So my h was -3. And then I'm going to first do -8, comma 3. And then -3 plus 8, comma 3. So my two vertices are -11, comma 3, and 5, comma 3. These are my vertices. My co-vertices use B. So for my co-vertices, and again, the minor axis is Y. So for the co-vertices, it's going to be H, comma, K, plus or minus B. So here, it's -3, comma, 3 minus 4, and then -3, and then 3 plus 4. So -3, -1, -3, +7. These are my co-vertices that I'm going to graph. And then lastly, the two focus points. So here, it's on the major axis. So for the focus point, h plus or minus c, comma k, major axis, the bigger number was under the x squared. So it'll be -3 minus 4 square root 3, comma, and my k value was +3. And again, I just leave it like that. I can't combine an integer with a radical. And then -3 plus 4 square root 3, comma 3. And these are my focus points. Now, for graphing purposes, what we can do here, again, is approximate it. So this is actually going to be the order pair -9.9, comma 3, and 3.9, comma 3. These will be the order pairs for the focus. Again, you're approximating the square root of 3 to be about that 2 point. Square root of 3 is in between square root 1 and square root 4. So this is 1, this is 2. So actually it's about 1 point, what did I say it was on the other? Oh, about 1.7. Again, if you said 1.5, that's fine. So then what I'm doing here with this order pair is I'm doing -3 minus 4 times 1.7, and then comma 3. So once I multiplied this and subtract it, I end up getting -9.9.
Oh, okay.
Does that make sense? And then the same thing here. All right, so let's graph these. So I need vertices at -11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then 1, 2, 3, 4, 5. And then it goes up to 3. 1, 2, 3. Okay, so I have my vertice at -11, +3, and +5, +3. These are my vertices. I also have my center point, which is at -3, +3. And then I have my co-vertices. They're located at -3, -1, and -3, +7. So these are co-vertices. Then you'll add in your two focus points, which again is approximation, so almost to the 10, and then on the same major axis, and then over here around the 4. These are the focus points. And now connect your red and your blue dots and make your ellipse. Slide actually teaches you what eccentricity is, and really it's the ovalness of the ellipse. Again, all you're doing is taking C over A. Webassign will accept a radical in the denominator, and you don't even have to break it down. Okay? However, on an SAT, they may expect you to simplify and rationalize. But this is what eccentricity is. Webassign will ask you for it. And you're already going to find your A and your C value anyways, because you need the A value to find the vertices, and you need the C value to find the focus points. So this is where we're going to stop as far as the notes for today. Tomorrow we will finish up these notes and we will learn how to write the equations of the ellipse.